Hello students, welcome back to the maths class. In today's class, we shall learn about section formula. So here, let P and Q be the 2 points. The position vector of the point P is OP and the position vector of the point Q is OQ. Then the line segment PQ is divided by the point R in two ways, either internally or externally. Let us take up the first case where point R divides PQ in the ratio m:n internally. So according to that, therefore the line segment PQ is divided by the point R in the ratio m:n. So we can write it as PR by RQ is equal to m by n. Therefore, n into vector PR is equal to n into vector RQ. Okay, so let us find what is PR and what is RQ. From triangle, you can see here the triangle OPR. From the triangle OPR, by applying triangular law of vector addition to the triangle OPR, so we can write vector OP plus vector PR will be equal to vector OR. Therefore, you can write this as vector PR is equal to vector OR minus vector OP. Okay, next, let us consider the triangle ORQ. So if I consider the triangle ORQ, again apply the triangular law of vector addition. So we can write vector OR plus vector RQ is equal to vector OQ. Therefore, you can write vector RQ as vector OQ minus vector OR. So we know what is vector PR and vector RQ. Therefore, n into vector PR, which is equal to n into vector RQ, can be written as n into vector PR can be written as vector OR minus vector OP, which is equal to m into vector RQ can be written as vector OQ minus vector OR. The vector PR is represented as the other form of representing a vector. Here I have represented vector OR as vector R, vector OP as vector A, and vector OQ as vector B. Therefore, n into vector OR we had represented as vector R minus vector OP, which is vector A, which is equal to m into vector OQ is vector B and vector OR is vector R. Let us simplify this. So, before I erase that part, I want everyone to write it down this because this will be asked for 3 marks. Okay, when in vector algebra, when they ask for 3 marks, usually they ask section formula, either the internal division or the external division for 3 marks. You should write this explanation and also the case. It depends on which case they have asked. If they are only for internal division, if you write only for internal, it will be enough. Or else, if they ask external, you write this explanation and the external. When I solve for external, if you write so much, then that will be enough. So let us simplify that. So here continuing n into vector R minus n into vector A, which is equal to m into vector B minus m into vector R. Now let us simplify further by grouping all vector R terms to one side. So I write this as n into vector R plus n into vector R is equal to m into vector B plus n into vector A. So vector R is common. We get it as m plus n, which is equal to m into vector b plus n into vector a. Therefore, vector r is equal to m into vector b plus n into vector a divided by n plus 1. Hence, the position vector of the point R, which divides P and Q internally in the ratio m is to n, as given by position vector R OR is equal to m into vector B plus n into vector A divided by n plus n. So much you should write if they ask for internal division. Next, let us see the next case, that is case 2, where the point R divides PQ externally in the ratio m is to n. Let us take up the next case where the point R is dividing PQ externally in the ratio m is to 10. When we say externally, means we are actually referring to the point R, where actually it is. So it is like I can say outside PQ. So this will be P to R is m and Q to R is n. So let us write the ratio of the line segment. So PR by QR. Now PR by QR is equal to m by n. So PR is n and then QR is n. So this will be n into vector PR is equal to m into vector QR. You should actually write it in this format. You cannot change RQ, because in vectors, if you change the initial and the terminal point, then you can say the negative vector, this vector is negative of vector RQ. So you should see here, PR when I write, the initial point is P and the terminal point is R. When I write QR, the initial point is Q and the terminal point is R. So therefore, now let us take the triangle. So from triangle OPR, so this big triangle OPR, this triangle, leave off this middle line. So OPR, from the triangle, we can write vector OP plus vector PR is equal to vector OR by applying triangular law of vector addition. Hence, vector PR is equal to vector OR minus vector OP. Next, consider the triangle OQR. So this triangle OQR. So from the triangle, again apply the triangular law of vector addition. So you can write vector OQ plus vector QR is equal to vector OR. Therefore, vector QR will be equal to vector OR minus vector OQ. Okay, therefore, now this n into vector PR, which is equal to m into vector QR, can be written as n into vector PR can be written as vector OR minus vector OP, which is equal to m into vector QR as vector OR minus vector OQ. Now, what we are going to do is, we are actually representing this vector in another form. So, vector OR is represented as what? Vector R minus vector OP represented as vector A. So, M into again vector OR, which is vector R, and vector OQ, it is vector B. So simplifying further, n into vector r minus n into vector a, which is equal to m into vector r minus m into vector b. Again group all the r vectors to one side. So here what I do is m into vector b minus n into vector a is equal to m into vector r minus n into vector r. Therefore, m into vector b minus n into vector a is equal to, if I take vector r common, I get m minus n. Therefore, we can write vector r is equal to m into vector b minus n into vector a divided by m minus n. Hence, for the position vector, of point R which divides P and Q externally in the ratio m is to n is given by what? Vector OR is equal to n into vector B bar minus n into vector A bar divided by m minus n. And here you have a special case. That case is for midpoint. Okay, that is if the point R divides PQ at midpoint. That is, then the ratio will be equal to what? M is same as n. This will take it in for internal division. If the ratio is m is to n, then the position vector of the point R which divides the line segment PQ in the ratio m is to n, that is at the midpoint, then this will be given by vector A plus vector B divided by 2. Okay, when m and n are same, then this will be vector A plus vector B divided by 2. This is a midpoint formula. Let us learn how to solve the problem on the concepts which we have studied till now. So here, in the first problem, they have asked us to find the magnitude of the following vector. So if you remember, when I wrote position vector, so any vector xi plus yj plus zk, yeah? If this is a position vector, then the magnitude of this position vector, we have written it as root of x square plus y square plus z square. Okay, so any vector in this form is called as component form, where x, y, z are called as scalar component. So in order to find its magnitude, you should take its scalar component, square it and add it under the root. So let us do the same thing. Whenever they ask magnitude, you should follow the same step. So here, when you take up the first question, you have vector A is equal to I cap plus j cap plus k cap. It is understood it is 1 I cap plus 1 j cap plus 1 k cap. So scalar components are 1, 1 and 1. To find its magnitude, this is how we represent for magnitude. Magnitude of vector A is equal to root of, so this will be 1 square plus 1 square plus 1 square, which is equal to root 3. Next, let us take up the next question. So here you have vector B is equal to 2i cap minus 7j cap plus, minus 3k cap. Therefore, magnitude of vector B is equal to root of 2 square plus, then you have minus 7 the whole square plus, then next you have minus 3 the whole square. Therefore, this will be equal to 2 square plus 4 plus 7 square 49 plus 9 square, 3 square, it is 9. So, if you simplify this, 58 plus 4, it is 62. Okay, next you can further simplify that. Next you have vector C, it is 1 by root 3 I cap, 1 by root 3 j cap plus 1 by root 3 k cap. So Finding its magnitude. So magnitude of vector C, should write this. Magnitude of vector C is equal to root of 1 by root 3 the whole square. So directly if you do, it will be 1 by 3. Again 1 by root 3 the whole square, which is 1 by 3. Again 1 by root 3 the whole square, which is 1 by 3, which is 3 by 3, which will be equal to 1. Okay. Next question, they have asked find the value of x and y so that the vectors 2i cap plus 3j cap and xi cap plus yj cap are equal. So if you remember the definition of equal vectors, two vectors are said to be equal if they have the same magnitude and direction. They have given that these two vectors are equal. See, when you have two vectors, any vector in the form of ai cap plus a1i cap plus a2j cap plus a3k cap and vector b is equal to b1i cap plus b2j cap plus b3k cap. If we say that these two vectors are equal, then it is understood that a1 is equal to b1, a2 is equal to b2 and a3 is equal to b3. If we say vector A is equal to vector B, then that implies that A1 is equal to B1. That is, I component of this vector is same as the I component of the vector B. Similarly for J and K. From this, now let us find what is the value of x and y. So easily you can see. So they have given that these two vectors are equal. So directly I can write x is equal to 2. And hence the value of y, here also these two vectors are equal. Therefore the value of y is equal to 3. I leave this problem for you as a homework. The next problem is similar problem where you need to find the value of x, y and z, and they have given that these two vectors are same. That is, they are equal. Okay. Next problem, write two different vectors having same magnitude. So the resultant magnitude should be same. So let us write vector A. So if I take it as I plus 2j plus 5k cap, any vector. Let us see what is the magnitude of this first. So vector I is equal to root of, that is, how to find magnitude we have just seen. So it is 1 square, 1, 2 square, 4, 5 square, 25. Therefore this is equal to root 30. Now I am going to write the next vector. So here what I do is 2i cap minus 5j cap plus k cap. Let us see what will be this. What will be the magnitude of this? So this will be equal to 2 square, it is 4, plus minus 5 whole square, again it is 25, plus 1 square, it is 1, therefore this will also be equal to root 30. So you can give infinite number of examples for the vectors having the same magnitude. What you can do is, you just write one vector, then if you interchange the scalar components and even the signs, then also you get the same magnitude. Write two different vectors having same magnitude. So let us write the vector A first. Here it is 2i cap plus 4j cap plus 6k cap. And vector B I write it as I cap plus 2j cap plus 3k cap. So if you see the direction ratios of vector A, which is 2, 4 and 6, and the direction ratios of vector B, which is 1, 2 and 3, they are proportional. Hence you can say that these two vectors are having the same direction. Like this, again you can give many number of examples. Next you have, they have given two vectors, vector A which is I plus 2j cap and vector B 2i cap plus j cap. Is the magnitude of vector A and magnitude of vector B are same, are equal? They are asking. Let us solve the first question, then let us move to the second part of it. So let us first find what is the magnitude of vector A. So magnitude of the vector A is given by, what is the coefficient of the I cap here? It is 1. So 1 square is 1 plus, next the coefficient of j cap is 2. So 2 square it is 4. I hope you people are understanding this. Therefore this is equal to root 5. Next, let us find what is the magnitude of vector b. So magnitude of vector b is, here it is 2 square. So 2 square plus next it is 1 square. So this will be equal to 4 plus 1, which is equal to root 5. So by looking at this, I can say magnitude of vector A is same as magnitude of vector B. So we got the answer for the first question. The next question they are asking is, are the vectors vector A and vector B equal? So if you see, vector A is 1 I cap plus 2 j cap and vector B is 2 I cap plus 1 j cap. For any two vectors to be equal, as we said, A1 should be equal to B1 and A2 should be equal to B2. That is, this component should be same as this one, I component. Here, if you see, here it is 1 and here it is 2. Whether 1 is equal to 2? No. So, vector A, therefore you can conclude vector A is not equal to vector B. Because A1 is not same as, A1 is not equal to B1 and A2 is not equal to B2. Find the vector joining the points P of 2, 3, 0 and Q of -1, -2, -4 directed from P to Q. So this is vector joining two points. If you remember the formula, there we had taken P of x1, y1, z1 and Q of x2, y2, z2. There the vector joining two points, vector PQ, is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Let us use the same formula here. So here you have 2 points P and Q. So by applying the formula, vector PQ, vector joining 2 points, PQ is given by x2 minus x1 I cap. So if I consider this to be as x1, y1, z1 and this as x2, y2, z2. So x2 minus x1 whole square. Or else I should write the formula here, plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Therefore, simplifying this, so x2 is what? -1 minus x1. x1 is 2 into I cap plus y2 is -2 minus y1 is 3 into j cap plus z2 is -4 minus z1 is 0 into k cap. Simplifying, therefore this will be equal to -3 I cap, therefore this next it will be equal to -5 j cap into plus, therefore -5 j cap, therefore the next it will be -4 k cap. This is the vector joining 2 points. Similar problem you have, find the scalar and vector components of the vector with the initial point I have given, so terminal point. Let us consider the initial point will be as A of 2, 1, then the terminal point I call it as B, that is -5, 7. Again this is by using vector joining 2 points. So how to find vector AB here? Therefore this, here there is no z coordinate, therefore you can just write x2 minus x1 I cap plus y2 minus y1 j cap. No need of writing z2 minus z1 k cap. So this will be x2 minus x1 I cap plus y2 minus y1 into j cap. So call this as x1 y1, this will be your x1 y1 and this will be your x2 y2. So vector AB is equal to, you should be very careful, they have specified which is your initial and which is your terminal point. The initial point coordinates you should take it as x1 y1 and the terminal point coordinates you should take it as x2 y2. In case you have z coordinate, then z2. Therefore vector AB is equal to x2 minus x1. What is our x2? x2 is -5 minus x1 is 2 into I cap plus next y2 minus y1. So y2 is 7 minus y1 is 1 into j cap. Therefore this is equal to -7 I cap plus 6 j cap. Okay, so this is one thing, but they have asked find its scalar and vector component. So you have a vector, any vector in this form, and this is called as component form of the vector. So from this component form of the vector, what is the scalar components? Scalar components are -7 and 6. Okay, -7 and +6. If you remember, okay, when we had a vector xi cap plus yj cap plus zk cap, then I told x, y, z are called as scalar components and xi cap, yj cap and zk cap is called as vector components. So just looking at this and you can say that x, y, z are scalar components of the vector xi cap plus yj cap plus zk cap. Then -7 and -6 will be the scalar component for the vector -7i cap plus 6j cap. Now let us see what is our vector components. So what will be the vector components? It will be -7i cap and plus 6j cap. You should even write with signs when you have negative sign, but when you have positive, it is understood. Let us take up the next question. In the next question, they have asked us to find the sum of the given 3 vectors. So sum means addition. So here I need to add vector A with vector B and vector C. So vector A is given by I cap -2j cap plus 3k cap plus vector B is given by -2i cap plus 4j cap plus 5k cap. Then we have plus vector C is given by I cap -6j cap minus 7k cap. So here if you have any vector in the form of vector A is equal to a1i cap plus b1j cap plus c1k cap and vector B is equal to a2i cap plus b2j cap plus c2k cap. Okay, then vector A plus vector B will be equal to, how to add two vectors is, that is nothing but a1 plus a2 into I cap, adding the I components, plus next b1 plus b2 into j cap, plus c1 plus c2 into k cap. This is the general form of adding, and this is for any 2 vectors. Similarly, you can do it for 3 vectors. The same thing holds for subtraction. So when you are subtracting, vector A minus vector B means A1 minus A2 I cap, B1 plus B1 minus B2 J cap plus C1 minus C2 K cap. With this result, let us find what is the addition of these 3 vectors. So according to this, see, this will be your A1, A2, A3. So add all those things. Okay, I hope you are not getting confused. So here, first I component is 1. Next it is -2. Next you have +1 into I cap. Okay, then plus adding all your j components. That is -2. Then plus, here we are adding, so plus in between. Plus, next you have 4. Next you have -6, plus of -6 into j cap. Then plus, now coming for your k components, that is you have 1 here. Next you have +5. Next you have plus of -7. I am writing plus here in order to not to get confused, because we are adding here. We are adding all 3 vectors into k cap. So let us simplify. Therefore, if you simplify, this becomes 0 I cap Next you have minus 2 plus 4, that is plus 2 plus 2 minus 6, it will be equal to minus 4 j cap. Next you have 1 plus 5, 6, 6 minus 7, you'll get minus 1 k cap. So this was the value by adding the given three vectors. Find the unit vector in the direction of the vector. Vector A is equal to 2i cap plus 3j cap plus k cap. So here we need to find the unit vector. If you remember the formula, so the unit vector in the direction of any vector A is given by k cap is equal to vector A divided by magnitude of vector A, which is equal to 2i cap plus 3j cap plus k cap divided by root of, now we already see how to find the magnitude. Therefore, root of 2 square, which is 4, plus 3 square, which is 9, plus 1 square, it is 1. Therefore, this will be equal to 2i cap plus 3j cap plus k cap divided by root 14. So, you can write it as 2i cap, 2 by root 14 into I cap plus 3 by root 14 into j cap plus 1 by root 14 into k cap. This is how we find the unit vector. Next, you have same question but different vector. You can solve it on your own. Next question, find the unit vector. Again you need to find, finally you need to find a unit vector. But what is the condition given here? In the direction of the vector PQ, where P and Q are the points. In the previous problem, they have directly given you the vector. But in this problem, first we need to find the vector. Vector PQ you need to find. This also we have just now seen how to find vector PQ when 2 points are given by applying the formula. So vector PQ will be given by x2 minus x1 I cap. I am writing the formula for vector joining 2 points plus y2 minus y1 j cap plus z2 minus z1 into k cap. So this will be your x1, y1, z1 and this point will be your x2, y2 and z2. So this is your x2, y2, z2. So simplifying, you can directly also do it. x2 minus x1, that is 4 minus 1. This is your x2. 4 minus 1 into I cap plus y2 minus y1 j cap, that is 5 minus 2 into j cap plus z2 minus z1 k cap 6 minus 3 into k cap. Therefore, 4 minus 1, 3 I cap plus 3 j cap plus 3 k cap. Now, for this vector, you need to find a unit vector. So, this vector, vector PQ, let me call this to be as vector A only. Okay, we can either represent it in any of the forms. So for this vector, for vector A, I am going to find a unit vector. So unit vector formula is given by vector A divided by magnitude of vector A. Therefore, this is equal to vector A is now given by 3i cap plus 3j cap plus 3k cap divided by square root of. Therefore, this becomes 3 square 9 plus 9 plus 9. So, this can be written as 3i cap plus 3j cap plus 3k cap divided by, so 9 plus 9 plus 9, root 27. Root 27 can also be written as 3 root 3. Therefore, 3i cap plus 3j cap plus 3k cap by 3 root 3. Okay, so when you take a common, what is common in the numerator? It is 3. This 3 in the numerator get cancelled with the denominator 3. Therefore, finally we can write it as 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Remember this formula? Very important. Here also we need to find unit vector, but for the vector joining 2 points. So first you need to find the vector joining 2 points, then for that vector you need to find the unit vector. Next question, find the vector in the direction of the vector. Vector A is equal to 5i cap minus j cap plus 2k cap that has magnitude of 8 units. So in order to find this, first for the given vector, we need to find a unit vector. So when we are able to find a unit vector, means for this vector, if we are able to find one unit, then if we multiply that one unit by 8, then we get a vector of magnitude 8 units. So let us first find the unit vector for the given vector. So unit vector definition formula is given by a cap is equal to vector A divided by magnitude of vector A, which is equal to 5i cap. Vector A is given by 5i cap minus j cap plus 2k cap divided by magnitude of vector A we should find. So root of, I'm going to write it directly. We should write 5 square, which is 25, then plus, always plus here. Then you have minus 1. So minus 1 whole square, it will be plus 1. Then again plus, then 2 square, which is equal to 4. So 25 plus 1 plus 4, which is equal to 30. Therefore you have 5i cap minus j cap plus 2k cap divided by root 30. Okay, now that has a magnitude of 8 units. So you should multiply. This is 1 unit. So if you multiply by 8, you will get as 8 units. So 8 into a cap will be equal to, if you multiply this final answer by 8, so 8 times 5i cap minus j cap plus 2k cap divided by root 30. Therefore, further simplifying, 8 into 5, 40i cap by root 30, then minus 8 into 1, 8j cap by root 30, then you have plus 8 into 2, 16k cap by root 30. Okay, so 40 by root 30 I cap minus 8 by root 30 j cap plus 16 by root 30 k cap. I hope you have understood. Then next problem you have a same kind of a problem, only other numericals are changed. I want everyone to complete this. Going on to the next question. Here we need to find the unit vector in the direction of the sum of the vectors. So there we used to say find the unit vector in the direction of a given vector, any vector. But here we need to find the unit vector in the direction of sum of the vectors. With sum, that is vector A and vector B. So first you should add these two vectors. So let us add vector A and vector B. So vector A is given by 2i cap plus 2j cap minus 5k cap plus vector B is given by 2i cap plus j cap plus 3k cap. We already know how to add or subtract any two vectors. So here it will be 2, then we are going to add, so plus, then again from vector B, the I component is again 2 into I cap plus, next here 2, we are going to add the vector, so plus in the middle, then the component of j cap of vector B is 1 into j cap plus, next minus 5 plus 3 into k cap. Therefore this will be equal to 4i cap plus 3j cap minus 5 plus 3 minus 2 k cap. So this is vector A plus vector B. Let me call this to be as vector C. Vector A plus vector B, I'll call it as vector C. So for this vector, we need to find a unit vector. So unit vector along vector C is, along the vector C is given by what? C cap. Now this will be equal to C cap, which is equal to vector C divided by magnitude of vector C. So vector C, which is equal to 4i cap plus 3j cap minus 2k cap divided by magnitude of vector C, which is root of 4 square 16, 3 square 9 plus minus 2 whole square, which is equal to 4, which is root 29. Therefore, this can be written as 4 divided by root 29 I cap plus 3 divided by root 29 j cap minus 2 divided by root 29 k cap. Understood? So why we are adding? Because they have asked us to find the unit vector in the direction of sum of the vectors. That is, we need a sum of vector A and vector B. So first find what is vector A plus vector B. For that resultant vector, you need to find the unit vector. You have a similar question that I will leave you for your assignment.